So I'm Srini Gowda. I head autonomous driving for Navistar and emerging tech. I've been doing autonomous since about 2017, and prior to that, I've been in the automotive industry since 2006. So today, I'll try and give you an overview of the challenges in mass adoption of autonomous vehicles. I'm sure you read the press in terms of Cruise and Waymo and what's happening in San Francisco, but I work for a trucking OEM. So I'll be concentrating on what it means in transportation in terms of taking on autonomous in a large scale. There's a lot to go through, so I'll try and keep it short. Any questions, feel free to raise your hand up and I'll be more than happy to answer. Before I dive into my presentation, just a quick video in terms of what Navistar is and where we are targeting towards sustainable mobility. So maybe I can just do a quick voiceover. So at Navistar, we're very much focused on looking at what kind of future we have for our children, right? So what are we leaving for our children in the future? Transportation accounts for a major part of global emissions. The trucking industry alone contributes to about 10% globally. So the idea is, how do we go from here in 2030 to 50% of our sales being all electric trucks? And that's the target. So this video is basically communicating that key message of sustainable mobility and how we can take that forward to a greener and more livable future than what we have today. So I've been in the automotive space for about 20 years. And I can fairly say that today is, this era that we are in today, the last 3 years and the next 10 years, is a transformative era. And the OEMs have a choice. It's innovate or die. Because of the changes coming in. You have autonomous, you have connectivity, you have safety, you have zero emissions. In this kind of ecosystem, how does an OEM survive? It's purely by adopting change and innovating at the same time. This does give rise to new business models. How do we compete with EVs and startups that are coming up on a daily basis? And how do we then provide value to the end customer who is actually interested in not just buying a product anymore? So it's not about truck sales anymore. It's more about the value add about the truck sales, right? So what kind of services that we can give customers who will use them. Innovative subscription models that customers subscribe to for years to come. Improving the autonomous ecosystem where customers can be part and parcel to that technology on a daily basis. If you look at what some of the startups are doing, they're providing a holistic service. Whether you look at Ironride, or if you look at Cruise, or if you look at anybody else, it's a one-stop shop in terms of the product offering. And that's something that the OEMs need to come up and change the game. Key drivers for autonomous truck adoption, one is safety. I'm sure you read the press in terms of how unsafe human drivers are. I'm not saying that's the case. I'm just saying that an AI driver is much more attentive, doesn't sleep, doesn't get distracted. So the metrics in terms of safety and achieving a much more safer environment goes on the side of AI. It needs to be still proven, though, in terms of the miles, accumulation, and everything else. So that's number one, safety. Second is the TCO. It makes incredible economic sense because from our math, a autonomous driver is 40% lesser on TCO cost to the customer today, and that's 40% per mile. So if it's $1 per mile in terms of running costs, if you have an autonomous truck, it comes down to something like 60 cents per mile. That's the cost saving of having an autonomous truck today. You then have the operator shortage. It's both the driver and it's a benefit because it's about giving time back to the drivers in long haul. They can actually go back and restricting drivers to more local routes, giving them back more family time. But it also reduces the stress of driving on them. Imagine doing 24/7 shifts, which the AI driver can do, which a normal driver cannot do. You need to give them breaks every 8 hours or 11 hours, according to legislation in the US. So this actually drives a lot of that economics when we pull the driver out in the ecosystem. Next, I'll quickly touch base on the legislation in the US for autonomous trucking adoption. It's kind of split. And what we really need is one common legal landscape across the US, all the states, that will enable autonomous legislation. For example, California has banned any testing for autonomous trucks. It's also banned a truck with hauling anything above 10,000 pounds, which pretty much mutes a testing for autonomous trucks. Texas is more forthcoming. They're very much on the go, more welcoming, more receiving for autonomous trucks. And what that means is they're investing heavily. For example, if you look at the I-10 corridor, the I-30, it's transformative. You have V2I infrastructure being implemented, a lot of AI being implemented to make that happen in the near future. Michigan, on the other hand, they do also have an intelligent corridor, but not on the level of Texas. So this is one of the key challenges as well in terms of mass adoption for autonomous driving. The legal landscape, just a quick overview before I go on to the next slides. The legal landscape shows that it's heavily divided. On one end of the spectrum, you have the unions who think that autonomous trucks will take away jobs from them, their daily livelihood, and hence why you have stiff resistance from them. You also have the railroad industry, which think that autonomous trucks will impact their bottom line because it's more cost competitive. You also have, on the other end of the spectrum, you have the OEMs, you have the big fleets, you have Schneider, Walmart, Werner, Pepsi, Coca-Cola. All of them are very much for autonomous driving because of cost save, the business model, and the scalability of autonomous trucking. The undecided is basically the public, the safety organizations, who are not really sure what the technology is capable of, what will it do to them. Is it a deterrent? Is it something that unlocks future business models? A quick slide on penetration in terms of what the fleets will be. And this is also to give you a glimpse of, you'll have about, let's just say, 1 million trucks, autonomous trucks by 2040, 2050. But then you'll also have traditional trucks side by side operating with autonomous trucks. The biggest challenge for the fleet is understanding how to maintain, manage, and implement one set of trucks which are still traditional, maybe running on ICE or maybe BEV by that point in time. Another set of trucks which are completely autonomous. To give you a use case example, if you're going to ground an autonomous fleet truck, you're not going to have drivers to go and replace them. So let's just say you have 500 trucks which are autonomous. You have a software issue, it's all grounded. What happens to the transport cargo? What happens to the costs? Who is going to bear the costs? So these things are a question mark, and this is where the ecosystem comes into play, and how do we develop that ecosystem to ensure smooth operations of the autonomous truck. I want to spend some time on the slide, but this is basically giving you an overview of what a hub-to-hub L4 autonomous ecosystem would look like. On the outside, it's divided into 9 particular sections. The first one is the TMS system, or the transport order system. That's the transport management system. It needs to be very well integrated with the AI stack, or STS, self-driving system stack. That's where you get the orders from, and the whole ecosystem starts functioning based on that order coming in. You have the fleet control center, or the control tower. That's the heartbeat of this entire system. That's what pretty much you'll have a person there, or people there monitoring a fleet of trucks 24/7, looking at the health of the truck, the route that the truck is taking, any emergency services that it needs to interact with, any stoppages, any alternate routes it needs to take, the weather conditions, if there's fires, winds, so on and so forth. So as you can see, there's a lot of TLC that needs to happen to make the autonomous truck work. It means more manpower, more resources in the control tower, because if you're pulling out the driver from the truck, you need that level of maintenance, you need that level of observation to make sure that the truck is performing to expectations. You then have the holding ground facilities, which are maintenance centers. More miles means more maintenance. So today, a traditional truck does about 1 million miles in 10 years. An autonomous truck will do 1 million miles in about 4 to 5 years' time because of the high usage. So high usage means more parts replacement. And that's why autonomous and BEV, or autonomous and electrification, is the holy grail for trucking in terms of the cost save and what we can achieve. The other part is, if you're looking at predictive maintenance, if it's going to be high, what does that mean to the bill of materials cost? How many parts can you stock in your PDP place? And how often are you going to replace these parts as well? The next part is the entire infrastructure for charging or fueling even. So you're looking at wireless charging. We're looking at chargers or fueling stations that can fill the trucks automatically even, so that you're reducing dependence on humans or labor in that space. Last but not least is the customer's plant. The stack needs to be very integrated with the customer's plant logistics systems, the TMS systems, for scheduling in and out of the warehouses. So if you look at how AI will influence the entire ecosystem, it's from start to end, and how AI can actually change or transform this is by being more reliable, having the right data sets that will actually drive this ecosystem, but also implementing the end-to-end solution in a manner that the customer can accept and willing to let the trucks go autonomously for them. So in summary, what I'd like to say is the autonomous ecosystem will provide a new platform. It's a revised platform where AI will be heavily used, heavily depended upon, and that's done through application of data. Now each autonomous truck will have petabytes of data coming out, almost per week per se. How is the data going to be managed? The cloud architecture, the resources, the upload and the download of the data link streams, the security aspects. So these things are something that needs to be worked on from the get-go and not postponed later on. The same data can be monetized as well, because you're looking at a data package that can be put on subscription for customers who want to understand how an ecosystem will work for autonomy. It's also an opportunity to deepen public-private partnerships. For example, if you take the Department of Transport in Texas, they're investing heavily in infrastructure, for autonomy, for electrification. This data will also prove that we can deepen our partnerships with them from the get-go.